Today in class we talked about how to convert numbers in standard form to scientific form and then backwards from scientific form to standard form. When going from standard to scientific, the first thing that you want to do is create a number between 1 and 10 by moving the decimal. Okay, if we have a number such as 1,850,000, notice how we have commas in that number, but there are no decimals. I can insert a decimal at the end of the number, and that would not change my current number, 1,850,000. So if you ever have a number to where there is no current decimal, you want to add one at the end. Okay. Then your goal is to move that decimal and so that you have a number created between 1 and 10. Or another way that you can think of it is you want to move the decimal until there is one number to the left of your new decimal. Okay. Notice if I move my decimal to where my pen is right now, there would be 3 numbers to the left of it. My goal is to have one number to the left of it, and so I am going to need to move my decimal between the 1 and the 8. Step 2 is to count the number of times that you moved the decimal, and this will be your power of 10. So if we count our humps or our loops, or however you want to think of it, there's going to be one loop per number. 1, 2, 3, 4, 5, 6. So I made 6 loops going from my old decimal to my new decimal, and that's going to be my exponent for the 10. If my standard form number is greater than 1, which it is, it's 1,850,000. If it is greater than 1, then your exponent will be positive. If your number is less than 1, then your exponent is going to be negative. Notice how my exponent is positive because I have a number greater than 1. Now, when you're writing in scientific notation, there's 2 parts. There's 10 to the exponent part, and there's the decimal piece that comes before the multiplication sign. So the decimal that I created when moving my little loops or moving my decimals between the 1 and the 8 was 1.85. I do not need to write all those zeros because this is what the 10 to the 6th power takes care of. Okay. If we look at example 3, notice how there already is a decimal point between those 2 zeros there. If I follow the same steps as above, my goal is to move the decimal point to where there is one number to the left of it. Now that number has to be either 1, 2, 3, 4, 5, 6, 7, 8, or 9. In order to have one number to the left, I need to move my decimal between the 7 and the 8. So I'm going to go ahead and count my loops. 1, 2, 3. I have 3 loops, so I have 10 to the 3rd power. However, notice that my original number that was in standard form is a number that's smaller than 1, so my exponent needs to be negative. Attach a multiplication sign in front, and we write our decimal piece that we just created out above it, or in front of it. So we have 7.826. Any number that is not 0, 0, 0, 0, or a ton of zeros, or so on and so forth. Any number that's substantial, such as between 1 to 9, you want to make sure that you write in your decimal piece. If you have a number then followed by a whole bunch of zeros, we drop off the zeros because the power of 10 takes care of that. On the back, we then go from scientific form to standard form. The steps say to move the decimal the same number of places as the exponent. If the exponent is positive, you move the decimal to the right in order to make the number bigger. So that should make sense. If I'm moving a decimal to the right, my number is going to get bigger. Any loop that when we move our decimal point, any loop that doesn't have a number inside of it, we add a 0 as a placeholder. If the exponent is negative, we move the decimal to the left in order to make the number smaller. And then we will add zeros in the placeholders if necessary as well. So notice in example 5 how my exponent is 7. The first thing that you want to do is you want to put your pencil, rewrite that decimal piece so that you have space to work and there's no obstructions when making your loops. You want to make sure when you make your loops, you're clear and precise so that you do not get sloppy and forget where zeros need to be placed. So notice how my exponent's 7. 7 is positive, so I move my decimal point to the right 7 loops. Your pencil is on the current spot where the decimal already is, and I'm going to make 7 loops to the right. 1, 2, 3, 4, 5, 6, 7. My new decimal point goes at the end of the number. Any loop that doesn't have a number inside of it, we put a 0. So you should add 1, 2, 3, 4, 5 zeros. Write your new number on the line, 7, 8, 3, and then 5 zeros. That number is bigger than 1, so we need to be putting commas where commas go. So for every 3 numbers to the right, moving right to left, 1, 2, 3, you put a comma. 1, 2, 3, you put a comma, and that number is 78,300,000. Whereas if we look at number 7, I have scientific notation. I'm going to write my decimal piece in below it so that I have space to make my loops. And my exponent is -6. Since it's negative, I move my decimal to the left 6 spots. My pencil is currently on the original decimal point, and here I go moving it 6 spots. 1, 2, 3, 4, 5, 6. My new decimal is in front of the number, which makes it important for you to also write in your answer. And then any loop that does not have a number involved or a number in it, you add a 0 to it. Write your new number on the line with the decimal itself. 0.00 0 0 0 8 3 4 5. Okay. One more, we'll just look at number 8. My current number is 3. Because there's no decimal involved, I can put a decimal at the end so that it doesn't change my number at all. And my exponent is -3, which means I'm going to take my current decimal point and make 3 humps to the left. 1, 2, 3. My current decimal point is now in front. Add zeros where the loops are, and your final answer is 0.003. Notice how up in example 5, it wasn't important for you to write that decimal point in the end there, because whether or not that decimal point is there, it still is the same number.